Alright, so let's take a look at a couple more problems. We've got three equations and three unknowns. They'll refer to this as a system of linear equations. They're telling us what z equals. So remember that our goal is to determine the value for each of these variables for x, y, and z. And they've already told us that z is equal to 3. So let's number these equations 1, 2, and 3, and let's substitute equation 3 into equation 2. So everywhere we see a z, we're going to replace it with its known value. We know that z is equivalent to 3. So we have that y plus 6 is equal to 5. If we subtract 6 from each side, these 6's cancel, and we have that y is equal to negative 1. So if we look at equation 1 is the only equation that has x, so we're going to sub y equals negative 1 into equation 1. So we have x plus 3y, but we're no longer writing the letter y because we know that this variable y is the same thing, is equivalent to the number negative 1. So we've got that x minus 3 is equal to 1. If we add 3 to each side, we're done. We have that x is equal to 4. So if we haven't made any silly mistakes, we've already got that z is equal to 3, y is negative 1, and 2 times 3 is 6, and negative 1 plus 6 is 5. And over here we've got x is equal to 4, and 3 times negative 1, that's 4 minus 3, and 4 minus 3 is equal to 1. So I'm pretty confident that this is the correct answer. It checks. Alright, so let's look at the next one. Same idea. Let's number these equations 1, 2, and 3. Let's keep in mind what our goal is. We're trying to determine the value of these variables x, y, and z. And right away we recognize equation 3 gives us the answer that z is equal to negative 4. So we're going to substitute this z equals negative 4, which I've numbered equation 3, into equation 2. So I'm going to copy down equation 2, but when it comes to copying the z, I replace it with the number that I know that it to be. So I've got y plus 12 is equal to 7. To solve for y, to get y by itself, we get rid of this term that's 12 by subtracting 12 from each side, and I get that y is negative 5. If I substitute this y equals negative 5, and the fact that z is equal to negative 4, into equation 1, it's the only equation that has the x, and that's what I'm trying to solve for right now, then we'll be able to tell people what x is. So we copy this equation 1 down, but I don't write the letter y because I know that that represents the number negative 5. And I don't write the number z because I know that z represents the number negative 4. So now I have one equation in one unknown, and I can solve for x here. So I've got that x minus 25 plus 28 is equal to 6. And so the negative 25 plus 28 is 3. Subtract 3 from each side, and I'm getting that x is 3. Alright, so if we take y, which is negative 5, minus 3 times z, which is negative 4, this is 12, and 12 minus 5 is 7. So the second equation checks. If I take x, which is 3, y, which is negative 5, and z, which is negative 4, what do I get when I add these together? Well, 3 minus 25 plus 28, and that's 28 minus 25 is 3, and 3 plus 3 is 6, and that's what this claims to be. So I'm pretty confident that this is the correct answer. Alright, so I hope that helps.